This lesson begins a new unit about rational expressions. And in this lesson, we're going to look at multiplying and simplifying rational expressions. So let's look at our key terms. A quotient or ratio of polynomials is a rational expression. Expressions that have the same value for all allowable replacements are called equivalent expressions. To multiply rational expressions, multiply numerators and multiply denominators. And finally, to simplify rational expressions, factor the numerator and denominator and remove a factor of 1. Now, reading through these, this should sound pretty familiar. Rational expressions is just another name for fraction. So anything that can be expressed as a fraction is considered a rational expression. The main difference you're going to see is we're going to see variables in our rational expressions or our fractions. So let's look at a couple expressions, and the first thing we're going to talk about is find all numbers for which a rational expression is not defined. So not defined, what does that mean? Well, recall that when you're dealing with fractions, there are two scenarios that come up that we have to discuss, and both of them involve the number 0. So we have 0 over any number equals 0, and then we have any number over 0 that we call undefined because we can't divide by 0. So what we have to do when we're dealing with rational expressions is find out what value would cause the 0 to be in the denominator. So when I look at my first problem, negative 1 over 5x, and the directions say find all numbers for which a rational expression is not defined, what they're really asking me is what causes x, or what would cause the denominator to be 0? Well, in this situation, x equals 0 would cause that denominator to be 0 because 5 times 0 would be 0. I can plug in any other number that I want, but if I plug in 0, I'm going to get not defined. So pretty much what you're going to do is you're going to take your denominator or look at your denominator and decide what values create that 0 in the denominator. So let's look at this next one. 3 over x plus 7. So in this one, it's pretty obvious to see what you would plug in, but if you're not too sure, all you have to do is take your denominator and set it equal to 0. It does not matter what's in the numerator because we've already discussed that if there happens to be a variable in the numerator, 0 is okay. But in both these examples, there's a number up there anyway. So just take your denominator, set it equal to 0, and solve your little mini equation. And that is going to give you the value of which this rational expression would be undefined. So some of them you can look and tell. If it's x plus 7, oh, well, minus 7 creates a 0. But if you're not sure, just take your denominator, set it equal to 0, and solve. Now in these examples, we are going to be simplifying rational expressions. So just like we reduce fractions, that's what we're going to be doing here. You're going to see variables involved as well. So the one thing you want to make sure is when you're working with these that your numerator and denominator are factored. Well, in this first problem, it's a monomial over monomial. Everything is already factored. Everything's being multiplied in my numerator, and everything's being multiplied in my denominator. So I don't have to worry about that in this problem. So what I like to do is just look at my numbers first. So with my numbers, I see 30 over 12. And if I saw just that fraction, I could definitely reduce it. 3 for sure goes into both, but you want to double check and make sure that you pick the largest factor. So as I look at it a little bit closer, I notice that 6 goes into both. So I would divide both the top and the bottom by 6, so that's going to get me 5, or 30 divided by 6 is 5, so I get 5 in my numerator. And I'm going to get 12 divided by 6, so that's going to be a 2 in my denominator. So I just simplified the number part of my rational expression. Now, look at your a's. So I see a to the 8th over a to the 1. Recall your exponent rules, that if the bases are the same, you subtract your exponents. So a to the 8th divided by a to the 1st would be a to the 7th. And with my b's, I have b to the 5th over b to the 4th, which would leave me a b on the top. Now notice I put my a and my b in the numerator of my fraction, because if you were to expand this, a to the 8th over a, I would have 8 a's in the numerator and only 1 in the denominator. So when I cancel out the one that they have in common, all of my leftovers would be in the numerator. If that a to the 8th would have been in the denominator instead, then I would have had my a to the 7th in my denominator. So now let's look at the next one. 8m minus 40 equals, or divided by 8m. The first thing you want to do is factor. So I need to factor my numerator, because remember, you can only simplify or reduce factors. A lot of people are tempted to see 8m and 8m and think, oh, those cancel. No, they don't, because the 8m in the numerator is being subtracted by 40, so that's not a factor. So we cannot do that. So what we can do is we can only simplify or cancel factors. So let's factor our numerator. 8m minus 40, they have a GCF, or an 8, in common. That's going to leave me with m minus 5 over 8m. Now I can cancel, because I have a factor of 8 that will cancel with this factor of 8. And recall, when you cancel, that's like 8 goes into 8 once, 8 goes into 8 once. And then the result, or my simplified answer, is what's left over. So it looks like m minus 5 over m. And again, do not cancel that m in the numerator with the m in the denominator, because the m in the numerator is not a factor. It's being subtracted. So let's look at this one down here at the bottom. Looks like we have a little bit more factoring to do. In the numerator, I have 4x squared plus 8x, so they definitely have a 4x in common. That's going to leave me x plus 2. Take out that GCF. And my denominator looks like it also has a GCF of, well, looks like 4x. And that leaves me with 3x squared plus, well, that would be 1. Now I can cancel my factors. 4 goes into 4 once, 4 goes into 4 once. My x's also cancel. And that's going to leave me my final answer of x plus 2 over 3x squared plus 1. We've got a few more here. So in this one, my numerator, x squared plus 25, okay, that cannot be factored. If it was x squared minus 25, it could, because it would be a difference of squares. But sum of squares does not factor. In my denominator of x plus 5 is already in simplest form. We can't do anything with that either. So guess what? This is already in simplest form. We cannot factor it any further. The next one, 9x squared minus 36 and 3x squared minus 12. I notice that my numerator is a difference of squares. So let's factor that. 9x squared, so that would be 3x and 3x. And the minus 36 would be a plus 6 and a minus 6. In my denominator, 3x squared minus 12, now that's not a difference of squares, but I do see that they have a GCF. So let's pull the GCF out of 3. That's going to leave me with x squared minus, if I factor a 3 out of 12, it leaves me 4. And as I'm looking at this problem, I realize I can do a little bit more factoring, actually, in the numerator and denominator. So I think I'm going to back up, because even though that numerator was a difference of squares, they actually have a GCF in common that I think will make this problem easier. So instead of doing the difference of squares in the numerator, what about the 9? It's still going to leave me with a difference of squares, but it's going to be a smaller difference of squares. And then we started factoring the 3 out here, and that also left me with an x squared minus 4. So you can see there's a lot of different ways to factor. Now eventually I would have been able to factor even further those 2 individual factors that I originally found, and I would eventually got to this, but it would have been more messy and a lot more steps. So I can go ahead and just take care of this in one step, because now I have x squared minus 4 over x squared minus 4. I don't have, even though it will break down, I don't have to break it down any further because they're going to cancel with one another. And then I'm left with 9 over 3. Well, that's easy. 9 divided by 3 is simply 3. So that one started out looking a little bit more complicated than it really was. So lesson learned, always pull out your GCF first. It's going to make the problem so much easier. Let's look at this last one on the screen. 2 trinomials, and I'm going to look for that GCF again. I don't want to end up in the same boat I was in a minute ago. So let's see if we can pull a GCF out of both. 2x squared plus 14x plus 20. They're all even, so I know 2 will come out. That's going to leave me x squared plus 7x plus 5. No, sorry, 10. And then in my denominator, those are also all even, but, so a 2 will come out, but when I see 6, 12, and 90, I know that 3 will actually come out of that. So that's going to leave me 2x squared plus, actually, you know what? I think 6 will come out. And I would have realized that because when I started pulling out all of that, I realized that they still had a common factor. So let's try pulling out 6. That's going to leave me x squared plus 2x plus, let's see here, 1, I believe 15. Okay, so now let's see if the x squared plus 7x breaks down. Well, don't forget your 2. So that would be x and x. Factors of 10 that add up to 7, definitely 5 and 2. My denominator, let's see, again, don't forget that 6. X squared plus 2x plus 15, so I definitely have my x plus x. Factors of 15 that add up to 2. I just realized that I have a sign issue. My plus sign that I have here should have been a minus sign. That's going to make it a little bit more factor. So now let's see if this will factor down. Factors of negative 15 that add up to 2. So x and x, definitely going to be my 5 and 3, and it would have to be a positive 5 and a negative 3 for it to work out. So yes, this will work. So now I see that I can cancel out x plus 5s. I know that 2 goes into 2 once and goes into 6 3 times. So that's going to leave me a final answer. Well, in the numerator, all I have left is x plus 2. And in the denominator, I have 3x minus 3. So that would be my solution, or my simplified answer for that last problem. Now let's look at multiplication. Multiplication is really the same thing